Section 2.5 is about solving system of inequalities. And solving system of inequalities isn't all that different than solving systems of equalities with the equal sign, except for we're probably going to have more points that make both solutions true, or not probably, we are. All right. So what we have to do is we have to graph. We're going to solve by graphing here, these inequalities by graphing. And what we realize is all the ordered pairs, or all the points that make both of these equations true, are solutions. So we're going to go ahead and we're going to graph these two equations first. This first one says y is greater than x plus 5. Well, we're going to treat it just like it's an equal to sign. It's still in slope-intercept form, y equals mx plus b form. All right, so I'm going to start up at 5. So up 1, 2, 3, 4, 5, put a mark. And I have a slope of 1. I'm going to go up 1 over 1, up 1 over 1, up 1 over, and so forth. All right. Now, you know that there's two differences when you are graphing inequalities, and that is you need to decide whether it's a solid or a dashed line, and you also need to decide where you have to shade. Since it doesn't have the equal to sign underneath it, it's a dashed line. So this is a dashed line all the way up. Okay. And then the second thing, we need to decide where we shade. It says greater than that. What I always do, I pick a point that's not on the line. 0, 0 is the easiest one, but when that's on the line, you got to go to a different one. But 0, 0 is not on this line. I'm going to pick it, and I'm going to test it. So my point is 0, 0. So I'm going to plug 0 in for y, and I'm going to plug 0 in for x. And is 0 greater than 5? Well, that's a false statement. So anything down here is not true, but anything up here is true. But right now, I'm going to wait to shade it, because in the system of equations, I need to have both equations on the graph before I get my solution. I'm just marking where I need to shade this line, where my solutions for this line is. And then after we graph this guy, we can decide where our total shade should be, where our overall solution is. So anyway, we're going to go down 2, and it's going to have an up 1 over 1 slope. So down 1, 2. It's going to have an up 1 over 1 slope. And actually, these are going to have the same slope of 1 over 1. And it's going to be a dashed line again, so that means these points on that line are not solutions to that graph. So there's our dashed line. And then it says y is less than x minus 2. I'm going to pick 0, 0, a point that's not on that line again. 0 is less than 0 minus 2, which is negative 2. That is not a true statement as well, so we have to shade on the other side of the line. This says shade this way. Where the shading overlaps is our solution to our graph. In this case, we have no solution. We have an empty set. All right, where the shading overlaps would be where we shade it. So say instead of this blue graph, instead of it being shaded up, everything would be shading this way. Well, where the shading overlaps is where our solutions are. That has to make both of them true. So our solution, we would have shaded everything down here, had that been the case, if we would have changed the sign to a less than sign. Okay, so let's go ahead and let's do another example here. Example 2, it gives us a graph x is greater than or equal to 0. Okay, so we got to decide what that graph is. Well, we should know what that is. We want to draw a line where no matter what, x is 0. Well, we know that when it's x equal to, it's a vertical line. Since it's that equal to sign there, it's going to be shaded up. Or sorry, equal sign is going to be a solid line. And it's going to go up and down here right on the origin. So no matter what, x is 0 right on that line. All right. For y is greater than or equal to 0, it's going to be a horizontal line. Here it's our y-axis, or our x-axis there. Sorry, excuse me. We need to decide where we shade both these. X has got to be greater than 0. X is bigger than 0 over here. Like we could pick a point 1, 1. 1 is greater than 0. All right, so we're shading that direction. For y greater than 0, again, pick 1, 1. And plug in 1 for y, so that's my ordered pair. 1 is greater than 0. So we're up here. What that is doing is it's limiting us to the first quadrant. Also, all our answers can only be in the first quadrant. And then we're going to graph these. Remember now, I could have 18 equations here, and our solutions have to make all 18 equations true. So since I have 3 here, I still can't shade yet. I can't shade this first quadrant. I still have to graph our other point. Let's put it in y equals mx plus b form. Y is less than or equal to negative x plus 5. All right. And now just a friendly reminder here. Say this is a minus y, and we would have got y by itself, that minus sign. Anytime you multiply or divide by a negative, you have to flip this sign, even when you're graphing. All right. So anyway, I'm going to go ahead and graph this. I'm going to graph it in red. I'm going to go up 1, 2, 3, 4, 5. I have a slope of negative 1 over 1, so I'm going to go down 1 over 1, down 1 over 1, and so forth. Okay? And it's going to be a solid line. It has the equal to sign on it, so we're going to draw a solid line. I'm not very good at drawing lines in this thing. And then it says y is less than or equal to negative x plus 5. We need to decide where we need to shade. 0, 0 is not on that line. So if I plug 0 in for y and 0 in for x, is 0 less than or equal to 5? Yes, that's a true statement. We'd be shading down. So all of our solutions inside of this triangle right here would be the solutions of our system of inequalities. So any one of those points, and any of the decimal points in between here, there's an infinite amount of solutions for this equation because there's that many numbers inside there. So we came up with all the possible solutions for that system of inequalities. All right. One thing that this chapter brings out to us is the vertex theorem is called. And it's saying this: if we graph a system of inequalities, the maximum and minimum values of the shape that comes up, like so that shape up there that we had was a triangle. The max and minimum value of a function is going to be one of those vertexes. So one of the points where the graph meets. All right. So I'll show you an example here. Find the max and minimum values of f of x, y equals x plus 2y plus 1 for the polygonal convex x. So polygonal means that it's going to make a closed shape, just like up top it made a triangle. All right. And it's set by these following inequalities. Right now it just looks like an example, but what's neat about how we do some of this stuff is we will analyze some businesses and how like maybe it costs them so much to make a certain product, and we'll graph it out for them, and we'll decide how many of each product they should make and stuff like that to maximize or minimize their profits. So here we go. We have those same stipulations again. X is greater than or equal 0. Y is greater than or equal 0. What we learned from that last example is that is limiting us to quadrant 1. All right, so we're in quadrant 1 here. So I took care of these two graphs, just basically saying that we're in quadrant 1. Let's go ahead and let's graph this guy here. I have, let's see, y would be less than or equal to negative 2x plus 12. And of course, 12 is off my grid. So here we go. So we know we're in the first quadrant, and we're going to say y is less than or equal to negative 2x plus 12. That means I need to start at 12. And I need to go down 1, 2 over 1. My slope is 2 over 1, negative 2 over 1, down 1, 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 2 over 1. And it's a solid line, so all the points on this line are solutions of the equation. And that is a terrible line. Fix that a little bit there. This thing's hard to draw with. There we go. All right. And then, of course, I got to graph that other line here. So I'll subtract my x over. So I have 3y is less than or equal to negative x plus 21 divided by a 3. Y is less than or equal to negative 1/3 x plus 7. So I start at 7. And I'm going to go down 1 to the right, 1, 2, 3. Down 1 to the right, 1, 2, 3. Down 1 to the right, 1, 2, 3. I only went over 2 there. 3. And so forth. And it's less than. I didn't go through the whole shading thing, but this line right here, we could have picked a point. We would have been shading down. It says it's less than or equal to. This one we're going to be shading down. So our solution set is this polygon inside here. And what the vertex theorem said, that the maximum and the minimum are going to come from our vertexes. So where our vertexes are, where our corners of our polygon here is going to be at 0, 7 is this guy. And then looks like we have one at 6, 3. Sorry, 3, 6. 3, 6. And we have one down here at 6, 0. And we have one obviously at 0, 0. All right, so we have we have 4 points where it meets, and when we plug these in, the highest number is going to be our maximum, the lowest number is going to be our minimum. So we're going to go ahead and we're going to plug, let's start out with 0, 7. So when I plug 0 in for x and 7 in for y, I get 0 plus 14 plus 1 is 15. So when I plug 0, 7 in, 0, 7, my value is 15. When I plug 0, 0 in, my value is 1. 0 plus 1 is 1. So these guys are done. When I plug 6, 0 in, 6 plus 2 times 0, because 0 is my y, plus 1 is 7. So 6, 0 is 7. And then we have one last one, 3, 6. So I would have 3 plus 12 plus 1. 3 plus 12 is 15, 16. So 3, 6. When I plug that in, I get 16. So my maximum value is 3, 6. My minimum, so I would write maximum here. And my minimum looks like at 0, 0. It'll be there. All right, so like pretend maybe a company wanted to decide whether they need to make 3 polos and 3 and 6 dress shirts. They're trying to decide between how many polos and dress shirts to maximize their profits. And we would say, well, that you need to in order to maximize your whole profits, you would be best off making 6 dress shirts and 3 polos, and that's going to do better than just making 7 dress shirts or just 6 polos. So that's where we're going to here, and I hope this helps. We will see you in class.